Yeah, good evening, children.
Good evening, ma'am.
Good evening, Dhanvin and Srijit.
Good evening, ma'am.
Good evening. So, online children, I've shared my screen. Is it visible? Good evening. I've shared my screen. Is it visible, online children?
Yes, ma'am. Yes, ma'am.
Okay. All right. Yeah. So, since uh, children from other schools have finished rational numbers and they also have linear equations in one variable for their exam, I'm opening multiple chapters at the same time. So, today, we're going to take the introduction to rational numbers. All right. Actually, last class, I started with exponents. And Srijit, that's the ongoing chapter for you, right? At school. We'll continue with that in the next session.
Yes, ma'am.
Yeah, we'll continue with that in the next session. So, so today we are going to take the introduction to the chapter rational numbers, and we'll also get into the exercise part of the chapter. All right. So before we understand what is meant by the term rational numbers, let's recall uh, the meanings of these terms. Natural numbers. So what is a natural number? Counting numbers are called natural numbers. Counting numbers. So when there are some objects lying on the table, how do you count? Do you say -3, -2, -1, 0, 1, 2? How do you start counting? You say 1, 2. Do you say 1, 1.5? No. So 1, 2, 3, 4, 5, 6. So all counting numbers are called natural numbers. Counting numbers are called natural numbers. Don't write anything. I'll send the notes later. Are called natural numbers. Okay. And natural numbers are represented by the letter N. They're represented by the letter N. So we say N is equal to, open a flower bracket, 1, 2, 3, goes on. The smallest natural number is 1. The greatest natural number cannot be identified. All right. Natural numbers are represented by the capital letter N. The smallest natural number is 1, and the largest natural number is not defined. You don't know the largest, you cannot say the largest natural number, right? Okay. Now, how many natural numbers lie between two natural numbers? When you take two consecutive natural numbers, what do you mean by consecutive? Numbers that come one after the other, one after the other. Consecutive numbers are numbers that come one after the other. So after 12 is 13, after 13, 14. So 12, 13, 14 are called consecutive numbers. Correct? 12, 13, 14 or 99, 100, 101, 102. They are consecutive natural numbers. Okay, now my question is, between two consecutive natural numbers, how many natural numbers do you find?
Zero.
You're trying to say 0 is a natural number between them? Zero. Answer 0 is different from no. Okay. Okay. So some of us, in fact, all of us here in the physical classroom have answered true or false for the statement. My statement is how many natural numbers lie between two consecutive natural numbers is my question. Okay, my question is, how many natural numbers lie between two consecutive natural numbers? Infinite. Online, yeah. Online children? Am I audible? Srijit and Dhanvin?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, my screen is visible, right?
Yes, ma'am.
Yeah. Please answer this question. How many natural numbers lie between two consecutive natural numbers?
Ma'am, none, ma'am. Nothing.
Nothing. Okay.
Oh, yes, ma'am. No, zero numbers.
None. Okay. So the correct answer is there is no natural number lying between two consecutive natural numbers. Let's understand that using an example. See now, 10 and 11 are two consecutive natural numbers. Now tell me a natural number between 10 and 11. There is no natural number between 10 and 11. There are many numbers lying between 10 and 11, but there is no natural number. Is there any counting number lying between 10 and 11 is a question. No. So how the question is how many natural numbers lie between two consecutive natural numbers? So between 10 and 11. Okay, so later we are going to see rational numbers. So then you will say there are many rational numbers lying between 10 and 11. But now the question is how many natural numbers lie between 10 and 11? No, none. There is no natural number. There is no natural number lying between two consecutive natural numbers. Clear? Okay. So counting numbers are natural numbers. Natural numbers are represented by the capital letter N. The smallest natural number is 1. The largest natural number is not defined. And this is how you represent natural numbers. This is how you represent natural numbers. N is equal to the collection of natural numbers is equal to open a flower bracket, starts from 1, 2, 3, and goes on like this. All right. Whole numbers. Whole numbers. So natural numbers including 0 form the collection of whole numbers. Natural numbers including 0. All natural numbers including 0 form the collection of whole numbers. So 0 and natural numbers. 0 and natural numbers. The collection of all natural numbers including 0 form the collection of whole numbers. Right? Now, say true or false. All natural, okay, and whole numbers are represented by the letter W. Whole numbers are represented by the letter W. Okay, so W is equal to open flower bracket 0, 1, 2, 3, and goes on. So the smallest whole number is 0, and the largest whole number, yeah, is not defined. Okay, all right. Now, say true or false. All natural numbers are whole numbers. All natural numbers.
Yes.
All N are W. All N are W.
False, ma'am. False, ma'am.
Okay. All natural numbers are whole numbers. Let's start from the beginning. 1 is a natural number. Is it a whole number? Yes. 2 is a natural number. Is it a whole number? Yes.
Yes, ma'am.
3 is a natural number. Is it a whole number? Yes. All natural numbers are whole numbers. Every whole number is not a natural number. Every natural number, all natural numbers are whole numbers. Okay, fine. If you say false, tell me one natural number which is not a whole number. Tell me one natural number which is not a whole number. Tell me. If you say this is false, then you should be able to justify the answer, right? So tell me. Then tell me one natural number which is not a whole number. So you're not able to justify. You're saying false, but you're not able to justify. Because 1 natural number, whole number. 2 natural number, whole number. 3 natural number, whole number. Tell me a natural number which is not a whole number. You cannot say because every natural number is a whole number. That's what what are whole numbers? All natural numbers including 0. What are whole numbers? All the natural numbers including 0. So that means all natural numbers are whole numbers. So all natural numbers are whole numbers. True. All whole numbers or every whole number is a natural number. Every
Zero is not a natural number.
every whole number is a natural number?
False.
Yeah, see, you can say true only if it is always true. Even if there is one exception, it is false. When you say true, it should be always true. There should be no exception. Okay. If you have even one exception, then it's false. So here, every whole number is a natural number, except for 0. Except 0, every whole number is a natural number. But 0 is a whole number which is not a natural number. So it's false. There is one exception, so it's false. Correct? Every whole number is a natural number. False, because 0 is a whole number. 0 is a whole number. It's not a natural number. 1 is a whole number. It's also a natural number. 2 is a whole number. It's also a natural number. But 0 is a whole number, but it's not a natural number. So it's false. So what makes the collection of whole numbers? All the natural numbers. All the natural numbers and 0 form the collection of whole numbers. So every natural number is a whole number. But every whole number need not be a natural number, because 0 is a whole number which is not a natural number. Integers. Integers are represented by the letter I. The letter represented by the letter I. So I is equal to, we don't know the smallest integer, -3, -2, -1, 0, 1, 2, 3. We don't know the largest integer also. So the collection of, so how do you define integers? The collection of all natural numbers, their negatives, including 0. The collection of all natural numbers. The collection of all natural numbers. Their negatives. Their negatives. Their negatives meaning the negative of 1 is -1. The negative of 2 is -2. The negative of 3 is -3. Okay. Including 0. I repeat, the collection of all natural numbers, their negatives, the negatives of all natural numbers, including 0, form the collection of integers. Natural numbers, their negatives, and 0. Natural numbers, their negatives, and 0. Natural numbers, their negatives. Including 0. This forms the collection of integers. The collection of all natural numbers, their negatives, including 0, form the collection of integers. Integers are represented by the letter I or Z also. Z, I or Z. Okay, it's some Greek letters, Zalen or something. Okay, so integers are represented by the capital letter I or Z. And this is how it's represented. Open a flower bracket. We don't know from where it starts, meaning we don't know the smallest integer. So like this, then show -3, -2, -1, 0, 1, 2, 3, and it goes on like that. So the smallest integer is not known. The largest integer is also not known. But we know that this forms the collection of integers. All right? Okay. So every natural number is an integer. True or false? Look at the collection and say, every natural number is an integer. Look at the collection. Is every natural number an integer?
Yes, ma'am. No.
Yes.
No, ma'am.
Every natural number is an integer. See there. See the collection of integers. Do you see every natural number? Yeah, we see all the natural numbers. Every natural number is an integer. Look at the collection of integers. You can see natural numbers here. No, what is the definition of an integer? All natural numbers, their negatives, including 0. Then if you say every natural number is not an integer, then what is the definition?
Ma'am, you're in mute, ma'am.
Yes, thank you. Yeah. What is the definition of an integer? All natural numbers, their negatives, including zero, form the collection of integers. And what's the statement here? Every natural number is an integer. Yeah, every natural number is an integer. True. Next, every integer is a natural number.
False.
Will you find all the integers in the collection of natural numbers?
Ma'am, negatives.
Yeah, you just see, you take -3. Is -3 an integer? Correct. Is -3 an integer?
Yes.
Yeah. Is it a natural number? No. -3 is an integer, but it's not a natural number. What's the statement? Every integer is a natural number.
False, false.
Yeah, no. Every natural, see, do you find all the natural numbers in the collection of integers? That's what it is. Do you find all the natural numbers in integers? Yeah, then it's true. Every natural number is an integer. That means every natural number is a part of the collection of integers. Every natural number is an integer means every natural number is a part of the collection of integers. Yeah, every natural number is a part of the collection of integers. The next one is every integer. Every integer is a part of the collection of natural numbers. No, because -3 is an integer. You don't find that in the collection of natural numbers. -10 is an integer, but you don't have negative numbers in the collection of natural numbers. Every integer is a whole number. True or false? Every integer is a whole number.
False.
False. Because again, if you take a negative number, -5, -5 is an integer. But okay, see, every integer, no, so take -5. Now, is it a part of the collection of whole numbers? Is a whole number. Do you find -5 in the collection of whole numbers? We don't have negative numbers at all in the collection of natural numbers and whole numbers. We don't have negative numbers. So every integer, so like -5, is a whole number. No, in natural numbers and whole numbers, we don't have negative numbers, but integers are made up of negative numbers also. So every integer, that means there are negative numbers also. Every integer is a natural number. No, false. Every integer is a whole number. False. But the other way is true. Every natural number and every whole number is an integer. Because what does integers have? Positive numbers, negative numbers, and zero. Right? Okay. So every integer is a whole number. True or false?
False.
Okay. Yeah. Now, how many integers? How many integers do you find between two consecutive integers? How many integers do you find between two consecutive integers? Between two consecutive integers, how many integers do you find? So there is no integer between two consecutive integers. Take two consecutive integers, -2 and -3. There is no integer between them because the integer, see, when you talk about the left side, okay, the number immediately smaller than 0 is -1. Smaller than that is -2. Smaller than that is -3. There is nothing between -2 and -3. There are numbers. There are rational numbers. There are fractions between -2 and -3. But there is no integer. There is no integer between -2 and -3. See now, again, if it's not convincing for you, what is an integer? An integer is a natural number or the negative of a natural number.
And a zero.
Zero. Now you tell me between -2 and -3, you tell me a natural number, or you tell me the negative of a natural number, or a zero between that. Zero is not here. Between this, there is zero is not here. You cannot find a positive number also there. Then tell me a negative number between minus. Then tell me a negative number between -2 and -3. No. Correct. So, how many integers do you find between two consecutive integers?
None.
None. None. All right. Okay. Now coming to rational numbers. So far, we understood the definitions of natural numbers represented by the letter N, whole numbers represented by the letter W, and integers represented by the letters I or Z. Okay, and this one, the smallest natural number is 1, and the list goes on. The smallest whole number is 0. Yeah, and we do not know the smallest integer, nor do we know the largest integer. Okay, so from where it starts, we don't know. We can't say. -4, -3, -2, -1, 0, 1, 2. It goes on like this. Right? Now coming to rational numbers. Rational numbers. Yeah. So numbers that can be expressed in the P by Q form. See, remember like this. Okay, before I tell you the definition, let's understand what it is and then I'll tell you the definition. Integer by integer is a rational number. Integer by integer is a rational number. But the numerator integer can be 0. This can be 0. The denominator should not be 0. That's the only condition.
You should not be.
Yeah, see, integer by integer, put this in your mind. Integer by integer divided by integer is a rational number. But the denominator integer should not be 0 because 0 is an integer, no? 0 is an integer. The denominator can be any integer, but not 0. Numerator can be any integer. It can be 0 also. Numerator can be any integer. It can even be 0. The denominator also can be any integer, but not 0. I haven't finished. Okay. All right. So integer by integer is a rational number. All right. So the numerator can be any integer, including 0. The denominator can be any integer, but not 0. Correct? This one should not be 0. Okay. Now answer these statements. Say true or false. -7 is a rational number. Okay. Rational numbers are represented by the letter Q. Rational numbers are represented by the letter Q, meaning quotient. Q for quotient. What is quotient? When you divide two numbers, the answer is called a quotient, right? Okay, and how does a rational number look like? Integer divided by integer, integer by integer. So it's kind of division there, right? So quotient, Q, quotient, okay? The rational numbers are represented by the letter Q. And Q comes from the word quotient, the first letter of the word quotient. And why quotient? Because rational numbers have a P by Q form. Integer divided by integer form, and when it's division, the answer is called a quotient, and that's why Q. I'm saying rational numbers are represented by the capital letter Q. And what is so you can ask doubts, children. I'm not saying don't ask anything. What I have explained so far, is it clear? This Q, what I'm talking about, capital letter Q. Okay, rational numbers are represented by the capital letter Q. Okay, yeah. Now, -7 is a rational number. Is a rational number. True or false? A rational number. -7 is a rational number. True or false? Srijit and Danvin? -7 is a rational number. True or false? Srijit and Danvin? Yeah. I want the answer.
False, ma'am.
Why?
Ma'am, because they are not looking like a rational number.
It doesn't look like integer by integer, right?
Yes, ma'am.
Okay. So can we write -7 as -7 by 1?
Yes,
We can write -7 as -7 by 1. Now, what's the definition? Integer by integer is a rational number. That's the simplest way we understand and remember.
ma'am, it is
Integer. Yeah, integer by integer is a rational number. Now, is this an integer? -7. See here, is it an integer -7? Yeah, negative numbers are integers. Yes, integer. Then is the denominator an integer? Yes. What is integers means? What should come to your mind? When you hear the term integers, what should come to your mind? Natural numbers, they're negative 0. Integers means natural numbers, they're negatives and 0. So what is 7? It's a negative of the natural number. What is -7? Sorry, what is -7? It's the negative of the natural number 7. What are integers? Natural numbers, they're negatives and 0. And what is -7? It's the negative of the natural number 7, right? 7 is a natural number. What is its negative? -7. So natural numbers and their negatives, including 0, form integers. Yeah, -7 is an integer. And what about 1? It's a natural number. What are integers? Natural numbers, negatives and 0. Yeah, it's an integer. And integer by integer is a rational number. So true.
Ma'am, -7 is not in the format integer by integer. Because it says -7 and there's no 1 below. If you are given like -7 by 1, then it is true. But you are just given -7.
Now, if I write 5, is it positive or negative?
Positive.
No, I didn't put a plus sign. Then how can you say it's positive? So it's understood it is +5, right? If it's a -5, then I have to say -5. In the same way, -1 can always be treated as -7 by 1. See, you cannot treat -7 as -7 by 2. -7 is not -7 by 2. -7 is not -7 by 3. It's not. But you can always write -7 as -7 by 1. You cannot write -7 as -7 by 0. So for any number, you can take the denominator as 1. It doesn't change its value. Right? So when it's -7, you should treat it as -7 by 1. And then it is of the form integer by integer. So it satisfies the definition of a rational number. How do you say true or false? It should satisfy the definition. What's the definition of a rational number? Disable your mic. Who's that? Tanvan, I think please disable your mic.
Okay.
Yeah. How do you say true or false? You must check if it satisfies the definition. The question is -7 is the statement is -7 is a rational number. That's a statement. You have to comment true or false. So rational number, what's the definition of a rational number? Integer by integer. So you must see if -7 satisfies the definition. You must see if -7 satisfies the definition. So take -7. You can write it as -7 by 1. What's the definition? Integer by integer is rational number. So now check. Yeah, this is an integer. Yes, this is also an integer. So integer by integer, it is a rational number. To answer true or false, you should see if the given number satisfies the definition. That's why we have definitions everywhere. What is the definition for natural numbers? All counting numbers. Whole numbers, counting numbers, and zero. Integers, natural numbers, their negatives, and zero. And rational numbers, integer by integer. Integer by integer, and yeah, you know that the denominator integer should not be zero. That you know. Even if I don't mention that every time. Yeah, I'm coming to that. I'm coming to that. All right. Now coming to the definition of rational numbers. A number that can be expressed in the P by Q form. A number that can be expressed in the P by Q form where P and Q are integers. Q not equal to 0. Okay, it's called a rational number. It's called a rational number. If you can express a number in the P by Q form where P and Q are integers, the numerator P is an integer, the denominator Q is an integer, but the denominator Q is not 0, then such a number is called a rational number. So this P and Q you were talking about earlier, right, Navneet? Yeah, this is small letter P and small letter Q. This is P by Q form. And rational numbers are represented by the capital letter Q. They're two different things. I understood your confusion. That's what I said. I haven't come to that. Small letter P by small letter Q, not capital letter P by capital letter Q. No. Small letter P by small letter Q. Capital letter Q is the symbol to which represents rational numbers. All right. So rational numbers always have a P by Q form, integer by integer form. Then coming to irrational numbers. Numbers that do not have a P by Q form, where P and Q are integers, Q not equal to 0, are called irrational numbers. Irrational numbers. Numbers that don't have a P by Q form. So then how will they look like? We'll see. So numbers that don't have a P by Q form are called irrational numbers. If a number has a P by Q form, it's a rational number. If a number does not have a P by Q form, integer by integer form, then it's an irrational number. So numbers that cannot be expressed in the P by Q form, where P and Q are integers, Q not equal to 0, are called irrational numbers. I told you I'll send the notes. Nice. Okay. So numbers that cannot be put in this form, P by Q form, where P and Q are integers, Q not equal to 0, are called irrational numbers. Now, rational numbers and irrational numbers together form the collection of real numbers. Rational numbers and irrational numbers together form the collection of real numbers. Now, see here. Imaginary numbers. Okay. So we'll start like this. So now see here. We'll just summarize what we have learned using a diagram. So we start like natural numbers, right? To the collection of natural numbers, when you include zero, it forms a collection of whole numbers. 1 minute, let me. Okay, I'm just trying to draw circles or ovals. Okay, so when you include 0, so natural numbers including 0 form the collection of whole numbers. Natural numbers including 0 form the collection of whole numbers. So whole numbers, if you add the negative numbers, that is whole numbers.
Integers.
Yeah, whole numbers already have 0, 1, 2, 3, 4, 5, 6. So if you include the negatives of the natural numbers, if you include -1, -2, -3, and so on, the negatives of the natural numbers, then that forms the collection of integers. You want to wash your face? One minute, children, just a minute. So natural numbers, including 0, form the collection of whole numbers. Whole numbers have 0, 1, 2, 3, 4, 5, 6, and all that. That is, whole numbers have the collection of positive numbers and 0. So if you include the negative numbers, that forms a collection of integers. And to the collection of integers, if you include fractions, that forms a collection of rational numbers. So every natural number is a whole number. You can use, see here, every natural number is a whole number. Every natural number is an integer. Every natural number is a rational number. Every rational number need not be an integer. So this, you can make statements like this and answer for yourself. Even if I do it for you, you can ask statements like this. Every natural number is an integer. The other way around. Every integer is a natural number. You ask yourself. That will be better. You understand the collection. Okay. So now, apart from rational numbers, we have something called irrational numbers that do not have a p by q form. So that's a separate circle altogether. That does not overlap with this. Yeah. Now, the collection of all rational numbers and irrational numbers form the collection of real numbers. Form the collection of real numbers. Real numbers are numbers that exist. Apart from real numbers, we have something called imaginary numbers, which you will not be seeing till standard 10. We'll be dealing only with real numbers till standard 10. Okay. So, so there's something called complex numbers, imaginary numbers. So you will see all that after 10th standard. Okay. So natural numbers, whole numbers, integers, rational numbers. Yes,
Can you give us an example for irrational numbers?
Yeah, I haven't come there. Yes, I'm going to tell you. Okay, so the collection of all rational numbers and irrational numbers together form the collection of real numbers. Real numbers are numbers that exist. Okay, and irrational numbers, there is no specific letter that represents irrational numbers, but real numbers are represented by the letter R. Irrational numbers, there's no specific letter. There's no specific letter that represents irrational numbers. Real numbers are represented by the letter R. So what are real numbers? So what are real numbers?
Existing numbers.
Yeah, not numbers that exist. Numbers that exist are called real numbers. Imaginary numbers are numbers that don't exist. Okay. All right. Okay. So we understood that irrational numbers are numbers that do not have a P by Q form. Then how do they look like if they don't have a P by Q form?
Irrational.
No. Yeah, but an example, we haven't come to that part. That's the problem when you've already learned in school. That's not a problem. That's the advantage you have when you have already learned it, but you have to wait for me to come there. Yeah, so we have already, learned this chapter, cubes and cube roots, squares and square roots. So from there you can give an example. So square root of 2. When you find the value of, root 2, you will see that the division, that long division process goes on. And the value you see there is a non-terminating, non-repeating decimal. So for now, I have to explain about decimals for you. So I'll finish that and then give you more detailed examples for irrational numbers. But now just to mention square root of 2, square root of 3, cube root of 10, fifth root of 15. These numbers, the values of these numbers are non-terminating, non-repeating decimals. So they are called irrational numbers. Fifth root of 15. That means you should say a number that when multiplied with itself 5 times will produce 15. A number into itself should give you 15. Yeah. So now coming to the, so these are examples, just to mention, these are some examples. Okay, so we'll just discuss about decimal numbers so that we can give more examples on irrational numbers. All right, now decimal numbers are broadly classified into two types. Okay, so we have terminating decimals. You're confusing everybody. Terminating decimals and
Non-terminating decimals.
non-terminating decimals. Non-terminating decimals. Okay, decimals are terminating decimals and non-terminating decimals. Non-terminating decimals are of two types. Non-terminating, repeating or recurring decimals. Repeating or recurring. Non-repeating or non-recurring. Non-repeating. I haven't come there. Non-recurring. Yeah. So if we have to write it as 1, 2, 3, terminating decimals, then non-terminating, repeating, or you can say recurring. Any one word you can use. Don't use both. Non-terminating, repeating, or non-terminating, recurring. Both mean the same. They're synonyms. They have the same meaning. Repeating, recurring, both have the same meaning. So you can say non-terminating, repeating decimal or non-terminating, recurring decimal. Okay. Same meaning. Repeating decimal, recurring decimal have the same meaning. Non-terminating, repeating decimal, non-terminating, recurring decimal, both have the same meaning. Okay, repeating decimal, then non-terminating, non-repeating decimal or non-recurring decimal. There's no place, there's not a short form or something. Don't write like this. There's no place, so I didn't want to, write it fully. So non-terminating, repeating decimal, non-terminating, non-repeating decimal. So these are the three decimal forms: terminating decimals, non-terminating, repeating or non-terminating, recurring decimals, non-terminating, non-repeating or non-terminating, non-recurring decimals. Now let's take examples to understand how these decimal numbers actually look like. Now, when I say 7.635, what do you mean by the word terminating? Terminating means it comes to an end. Terminate means it comes to an end. It halts, it stops somewhere. Terminate, stop. So terminating decimals, meaning they end at a particular point. So 7.635, look at the decimal part. The decimal part, it has only the decimal part, meaning it has only, this number has 3 decimal places. That means there are 3 digits after the decimal point, right? So it's a terminating decimal. See, the number can have even 10,000 digits after the decimal point, but it ends there. After 10,000 digits, it ends there. Terminating decimal. See, if I write 7.21213569871132569. Finish, that's all. Terminating decimal. Because it ends there. You should see if the decimal portion terminates. The decimal part. What is this one called? It's called the integral part. This one is the integral part. And this is the decimal part. The decimal part should terminate. It should stop somewhere. It can stop even after 10,000 decimal places or even 1 lakh decimal places, but it should stop. If it stops, if the decimal portion stops somewhere, then it's terminating decimal. Otherwise, if it goes on and on forever, it goes on forever, the decimal portion goes on forever, then it is a recurring decimal. Okay. So we'll see if it is recurring or non-recurring. Now this one you understood? Why is it a terminating decimal? Because it stops here. 212135698711325669. It ends there. Terminating decimal. Now an example for a non-terminating repeating decimal. Okay, we'll take an example for a non-terminating repeating decimal. So 7 point or 17.353535 goes on like this. Look at the decimal part. What do you see in the decimal part? The 2 digits 35, they go on forever. 35, 35, 35 and dots. That means the pattern continues. 35, 35, 35, 35. That pattern continues. That's why the dots. Wait. Okay, so 35, 35, 35 goes on like that. See, the dots indicate that the pattern continues forever. But the pattern is repeating. It's non-terminating because it goes on forever, but it's repeating because these 2 digits 3 and 5 repeat themselves. See, every word has a meaning. Why is it non-terminating? Because it goes on forever. Non-terminating. It does not end. The decimal part does not come to an end. So non-terminating. Why repeating? Because these 2 digits 3, 5, 3, 5, 3, 5, they keep repeating forever. Repeating because 3, 5 repeats itself, and non-terminating because the decimal portion does not come to an end. It goes on forever. That's why non-terminating, repeating. This is an example of a non-terminating, repeating decimal. You can also write this as 17.35 and place a bar on top of 35. Because 3, 5, these 2 digits 3, 5 repeat, right? So you can just write that repeating portion once and put a bar on top of it. Write it repeating. Don't write 17.35, 35, 35 and then don't put a bar. Just write that repeating block once. The digits that repeat, no, just write them once and place a bar on top of those digits. No, I have to finish. You can ask me anything. Let me finish. Okay, now look at this. Look at this example, 8.1379 4. Now, can you see this? That means non-terminating. If you see that, it's non-terminating. Or if you see a bar, it's non-terminating. If you see a bar or these dots, non-terminating. Correct, no? If you see a bar, it goes, those digits go on forever. They repeat forever. So non-terminating. Non-terminating means what? It does not come to an end. It does not stop. Okay, non-terminating. And what is repeating here? 4 is repeating itself. So how do you express it in a different way? 8 point, that is using the bar, 8.13794. Place a bar only on top of 4. Because 4 is the only digit that repeats. Don't put a bar on top of all these digits. That gives a different meaning. That means 8.13794, 13794, 13794 going on forever. But that's not the example we have given. That's not the example we have given. In this example, 4 is the only digit that repeats forever. 4 is the only digit that repeats forever. So how do you write this number using a bar? 8.1379. Only 4 repeats. No, place a bar on top of 4 only. So this how you write using the dots. See, using the dots, if you write 8.13794 and you put dots, no, it's very vague. How do you understand which is repeating? You're not giving a clue. You should give a hint of what is repeating. When you see the number, without any doubt, you should say that this is the repeating block. When I write 8.13794 and put dots, which is that part which is repeating?
Can be 13794.
You should write that 4 at least some 3 times like this. So yeah, okay, 4 is repeating.
Or 2 times.
Yeah, at least 2. Yeah. So if like say 8.137, suppose 94 is repeating. Write it at least 2-3 times and then put at least 2 times 9494 10 dots. Or you can write it as 8.13794 and a bar on top of the digits that repeat 9 and 4. 8.13794. Place the bar on top of the digits 9 and 4 only because only those 2 digits go on forever. So this is an example of a non-terminating because it's going on forever. Non-terminating, repeating decimal because 949494. Non-terminating, repeating decimal. Now, now we've understood 2 types of decimals, terminating and non-terminating, repeating. Terminating meaning the decimal part will come to an end. Okay, and non-terminating, repeating is non-terminating is the decimal part goes on forever. Repeating meaning one digit or a set of digits will keep repeating themselves. So it can be even one digit like 7.5 recurring, which means 7.555 goes on forever. So in the decimal part, one digit or a set of digits will repeat themselves. One digit can go on forever or a set of digits, 2, 3, 4, a set of digits can go on forever. So these are non-terminating repeating decimals. Now both these decimals have a P by Q form. We'll see how to put them in the P by Q form. Both these decimals have a P by Q form. Every terminating decimal has a P by Q form. That is why every terminating decimal is a rational number. Every terminating decimal is a rational number because you can write a terminating decimal in the P by Q form. Now to take a simple example, 2.5 is a terminating decimal. And you know you can write it as 25 by 10. You know it very well. 2.5 is 25 by 10. Don't you know that? 2.5 is a terminating decimal. And its P by Q form is 25 by 10. And what's 25 by 10? 5 5s are 5 2s are 5 by 2. P by Q form is 5 by 2. The P by Q form of 2.5 is 5 by 2. 2.5 is a terminating decimal. It has a P by Q form, 5 by 2. When you divide 5 by 2, the answer, the quotient is 2.5. 3.25. is a terminating decimal, and its P by Q form is 325 by 100. In the tables of 25, it will be 4, 8, 12, 13. And this is 4, 13 by 4. 13 by 4. So 3.25 is a terminating decimal. Terminating decimal because you can see it has 2 decimal places. That's all. 3.25 finished. The decimal portion comes to an end. So terminating decimal. In terminating, you don't have terminating, repeating, terminating, non-repeating. Terminating decimal is terminating decimal. Non-terminating decimals are non-terminating, repeating, non-terminating, non-repeating. Don't fix that for terminating. We don't have terminating, repeating, terminating, non-repeating. Terminating decimals are terminating decimals, where the decimal part comes to an end. Okay. So you saw that this terminating decimal, 3.25, has a P by Q form, which is 13 by 4. So anything that has a P by Q form is a rational number. Anything that has a P by Q form is a rational number. This is a terminating decimal. Its P by Q form is 13 by 4. And that's why this terminating decimal is called a rational number. Every non-terminating repeating decimal also has a P by Q form. We'll see how to put it in the P by Q form, maybe if possible in today's class or in the next class. How to write a non-terminating, or maybe I'll tell you now in some time, how to write a non-terminating repeating decimal in the P by Q form. Okay, so that also has a P by Q form, which is why it's a rational number. And the third decimal, non-terminating, non-repeating decimals, they don't have a P by Q form. And they are called irrational numbers. So every terminating decimal is a rational number because it has a P by Q form. It has a P by Q form. Every non-terminating repeating decimal has a P by Q form. That's why this also is a rational number. A terminating decimal has a P by Q form. That's why a terminating decimal is a rational number. Every non-terminating repeating decimal also has a P by Q form. That's why a non-terminating repeating decimal is a rational number. The third one, non-terminating, non-repeating decimals. They don't have a P by Q form. You cannot put them in the P by Q form. And because they don't have a P by Q form, they are called irrational numbers. If a decimal has a P by Q form, it's a rational number. If a decimal does not have a P by Q form, it's an irrational number. I can say more about it. I'll tell you later. What are the 3 types of decimals? Terminating decimal, non-terminating, repeating decimal, non-repeating decimal. Now, terminating decimal has a P by Q form. You can express a terminating decimal in the P by Q form. So it's a rational number. A terminating decimal is a rational number. Non-terminating repeating decimals also have a P by Q form. So it's a rational number. This one does not have a P by Q form. This one does not have a P by Q form. And that's why we call it an irrational number. Now let's take an example of a non-terminating repeating decimal. Let's say 13.615, where 15 repeats. Okay. Now this we already saw. Terminating decimal we already saw. Say like 5.6 is what? Terminating decimal. What's its P by Q form? 56 by 10. That we've been doing since 5th standard, I think. 5.6 is 56 by 10. Terminating decimal. P by Q form is 56 by 10. And you should simplify. 220, 8 times 2 5s are. So 28 by 5. When you divide 28 by 5, the quotient is 5.6. When you divide 28 by 5, the quotient is 5.6. Okay. Now what is 13.615 recurring? 13.615 recurring. What is it? It's an example of a non-terminating repeating decimal. Repeating decimal. Now we'll see how to put this in the P by Q form. Srijat and Danvin, are you there, both of you?
Yes, ma'am. Yes, ma'am.
Very good. Okay. So step 1 is let x be equal to 13.615151515 going on forever. So let x be equal to the given decimal number, the given non-terminating repeating decimal number. Let x, you can say let y be equal to z. You can assign that number to any variable, x, y, z, a, b, c, any letter, any variable. Okay. Now, how many digits repeat in the decimal part? In the decimal part, how many digits are repeating? 2, 1, 5, 1, 5, 1, 5. 2 digits are repeating. The 2 digits 1 and 5 go on forever, correct? In the decimal portion, the 2 digits 1 and 5, they go on forever. Yes or no? No?
Yes, ma'am.
Yeah. In the decimal part, the digits 1 and 5, they go on forever. So how many digits repeat? 2 digits. 2 digits means you should use the number 100. If 1 digit repeats, use the number 10. If only 1 digit repeats, use the number 10. If 2 digits repeat, 100. 3 digits, 1000. 4 digits, 10,000 and so on. Now, since 2 digits repeat in the decimal part, find 100x. Find 100x. 100x. 100x is equal to. Now, 100x is equal to. When you multiply by 100, you must shift the decimal point to the right by 2 places. When you multiply by 100, you must shift the decimal point to the right by 2 places. So this is x. What is 100x? X into 100. You're multiplying x by 100. When you multiply x by 100, what will happen? 1, 2. The decimal point will shift here. See, what's the number? 13.615. 6151515 going on forever. When you multiply this by 100, 1, 2, the decimal point will move here. So 100x is equal to 1361.5. Move the decimal point there. It was here. 1, 2. It comes here. So what is it? 1361.5. 0.5. 51515 going on forever. You can write that repeating portion, you can write how many ever times you want. See, it's going on forever. You write how many ever times you want. So since 2 digits 1 and 5 repeat, we use 100. You should find 100x. And how to find 100x? X into 100. X into 100 is 100x. How will you multiply x with 100? You should shift the decimal point to the right by 2 decimal places. By 2 places. I'm showing you again. See here. 6151515 going on forever. When you multiply by 100, this decimal point 1, 2, it will come here. So it is 1361.5151515 going on forever.
What if we 10x?
You will not get it. I'll tell you when you can multiply by 10. Only if 1 digit repeats, you can multiply by 10. All right. Now, what you do is, you can call this equation 1 and you can call this equation 2. Equation 1, equation 2. Now, you must perform equation 2 minus equation 1. That is 100x is equal to 1361.5, 151515 going on forever. Oh, yeah. Thank you. Hundred x is equal to 1361.5, 151515 going on forever. And x is equal to, write it, see, you're dealing with two decimal numbers. Place the numbers carefully. So it's 13.6151515. You can stop. Stop, enough. You have below all these digits, you have some digits. That's enough. Going on forever. Now you must subtract these two equations. You must subtract. You must subtract these two equations. What is 100x minus x? 99x. And when you subtract here, 5 minus 5, 0. 1 minus 1, 0. 5 minus 5, 0. 1 minus 1, 0. 5 minus 5, 0. 1 minus 1, 0. So literally what's happening is, the decimal part, you can just cancel out like this here. 151515, 151515. So it'll be 0, 0, 0, 0. Why write 0, 0, 0? Okay. So here 5 minus 6.
1.
Should borrow. So 0. And this becomes 15. 15 minus 6, 9. Decimal point. Again borrow. 5. 10. 10 minus 3, 7. 5 minus 1, 4. 3, 1. Okay. Next, I'll give you a question. You have to answer it. I'll not help you. I'll give you 3 questions, not 1. Correct? So 99x is equal to 13479 by 10. This is the next step. Shift the decimal point. 13479 by 10. I've shifted the decimal point by 10. X is equal to 13479 by 10. 99 will come for division into 99. 99 from here will come for division. Now, what's the test of divisibility for 3?
The digits, we need to add the digits, and the sum should be multiple of 3.
Yeah, if the sum of the digits is divisible by 3, let's find the sum of the digits. It is
24.
So 9 plus 1, 10. 10 plus 3, 13, 17, 24. Yeah, it is divisible by 3. So simplify. 3 4s are 12. Because this is divisible by 3. 33 times. 99 is divisible by 3, 33 times. The numerator is also divisible by 3. How did you check? Using the test of divisibility. 1 plus 3, see here. Find the sum of the digits. 1 plus 3, 4, 4 plus 4, 8, 8 plus 7, 15, 15 plus 9, 24. 24 is divisible by 3. 24 is divisible by 3. So this whole number is also divisible by 3. 3 4s are 12, 1 remains. 3 4s are 12, 2 remains, 3 9s are 27, and 3 3s are 9. Is it again divisible? Is it further divisible by 3? It's not divisible.
No, ma'am.
See if it's divisible by 11.
No, ma'am.
Do you remember the test of divisibility for 11?
Yes, ma'am.
Correct. Can be 0 or a multiple of 11. Correct. Okay. So it's not a multiple. Yes. 4493 is not divisible by 11. Okay. Now, the denominator, in the denominator you have 10, right? Can you simplify the numerator and 10? No. Because 10 is divisible by 2 and 5. But the numerator is not divisible by 2 and 5. Then the other number. In the denominator, we have 33. Is 33 divisible, 33 is divisible by 3 and 11. So is the numerator divisible by 3 or 11? No, it's not divisible by 3, not by 11. You should use a test of divisibility for all this. So this is the simplest form. X is equal to 4493 divided by 330. This is the P by Q form. This is the P by Q form for the decimal number 13.61615 recurring. What's your question?
Oh no, what? Can we leave it just like that?
No, no. A rational number should always be put in the simplest form. What are you doing, Anirudh?
Also, ma'am, how to know that it's the simplest form?
That's what I was telling. I was easily able to make a that was exactly what I was telling. How do you know? See, now the question at the end of it, the question has arisen. How do you know that you can simplify? So I'm doing it again. Listen. There is one number in the numerator. There are two numbers in the denominator. Take up the number in the numerator and any one number in the denominator. Let's say 10. So we are now taking up this number in the numerator and 10 in the denominator. Now this 10 is divisible by 2 and 5. If you can simplify using the tables of 2 and 5. Now ask yourself, is the numerator divisible by 2 or 5? Don't do this. Look at the number and say, is a number divisible by 2, the numerator? No. 5? No. If you want to simplify this number and this number, you can do it with 2 or 5. 10 is divisible by 2 and 5, but the numerator is not divisible by 2 or 5. Then you cannot simplify, right? What are the tables you want to use? 10 you can divide only by 2 or 5. Or you would say 10 itself. Okay, 10 itself. Is the numerator divisible by 10? No. So simplification of the numerator with 10 is not possible. Leave it. Now take the numerator with the other denominator, which is 99. 99 is divisible by 3. It's divisible by 11. Check only the prime numbers. Now you'll ask me why you're saying only 3 and 11. There are so many other numbers. Yeah, because I'm using only the prime numbers. I won't say 9. 9 I won't say because if it's divisible by 3, you can do 3 first, right?
Okay.
If it's not divisible by 3, it's not divisible by 9. If a number is not divisible by 3, it's not divisible by 9. So now we are checking for this number in the numerator, 99 in the denominator. This number 99 in the denominator is divisible by, is it divisible by 2? No. 99, is it divisible by 3? Yes. Then you know it's also divisible by 11, correct? 99 is divisible by 3 and 11. So you must check the numerator number if that is divisible by 3 or 11. That you will only make it still difficult. Don't multiply. Huh? That will become more difficult for you. That will be more difficult. Don't do that. You should first simplify and then multiply. You should not multiply. You never multiply. Don't multiply the denominators and then try to simplify.
We can do it, but it's not.
Yeah. Nothing is hard. Like as long as you know your tables well, the test of divisibility and all that, nothing is hard. Yeah. Okay. So now the denominator 99 is divisible by 3. The numerator, find the sum of the digits. It is divisible by 3. So simplify this and this. 3 33 times. 3 4s are 12. 3 4s are 12. Then 3 9s are and 3 3s are. Now, for 10, see, now you don't have to check 4 4 9 3 and 10. We already checked. It was not divisible. So leave it. That's all. Now you're not going to check the numerator and 10. You will only check the numerator and 33 now. Now 33 is further divisible by 3 and 11. Is the numerator divisible by 3? No. Use a test of divisibility? No. 11 also no. Using the test of divisibility, the numerator is not divisible by 3, it's not divisible by 11. So that means you cannot divide, you cannot simplify this any further. So x is equal to 4493 divided by 330. Have I simplified correctly my division? 4, 1 carry over 4, 2 carried over, 3 9s are 3 3s are this. Now, when I use the calculator, and find 4493 by 330. Thank you. Okay, so I'm using the calculator to find the value of 4493 divided by 330. And see, 13.61515. So Dhanvin and Srijit, yes. So if you can reach out for a calculator, pick it and grab the calculator and find the value of 4493 divided by 330. And the calculator shows 13.61515. You can't see it. 13.6151515 going on forever. This calculator can show only 14 digits. So that does not mean it's a terminating decimal. Yeah. Computer. Not computer, calculator. If you run a program. Okay. So you see that now you believe that every non-terminating repeating decimal has a P by Q form. See here, integer by integer. Now, supposing the number was 13.615, how do you put this in the P by Q form? Only if it's a non-terminating repeating decimal, you should use this X method. I call this the X method. That's not a standard way of saying. We'll use that in the class, X method. So this X method is used only for non-terminating repeating decimal. If it's a terminating decimal, 13.615. This one is 13615 by 1000. That's all. 13615 by 1000. For this, for 13.615, you should not use this X method. X method is only if there's a bar like this. No, one bar is everything. Supposing the decimal number is 13.615. Its P by Q form is 13615 by 1000. And then you should simplify. Should never leave it like this. Should always write the P by, write the, you must always write the rational number in its simplest form. Always. So you can divide by 5. I'm not doing that now. All right. So we'll just see the X method again. The given number is a non-terminating repeating decimal. In the repeating block, 2 digits are repeating. 2 digits repeat in the repeating block. So the number is 100 because 2 digits are repeating, 1 and 5. So the number is 100. We need to, so assign this number, the given number to X. Let X be equal to the given number. Then find 100X. call this equation 1, call this x equation 1 and 100x equation 2. Then you should perform equation 2 minus equation 1. Write the two equations one below the other and subtract. Place the decimal point, in a column, and make sure that below every digit there's only one digit. Don't write it clumsily, like if you write 1 5 1 like this, and then you don't place the digits properly, like 1 3 point and 6 1 5 1 5 like this. You'll go wrong. Place the digits carefully one below the other. Right? Yeah. So now any questions, Srijit?
No, ma'am.
Okay. Use a rough book. You people can do it on the last page, because we have the notes of this chapter to be completed. So if you have another book, if you have a rough book, you can do it in that. Otherwise, use the last pages of your book.
Ma'am, do we want to copy this, ma'am?
No, I'll send it later. I'll send the notes later, Srijit. Sorry.
We should write all the questions and
No.
we can discuss. How can before we discuss it? Before we discuss.
Okay. Yeah, I think take down all the questions. I'll just present the screen so that you can just have a look at the procedure and work. Yeah. So take down all the questions. Take down all the questions. 1, 2, 3. Srijit, taken all the questions? Srijit, have you taken all the questions?
I'm taking the.
Okay, so I'm presenting.
Taken them.
Okay. Yeah, so you can take help of the slide to answer the questions. Yeah, I'll come back in 10 minutes. I'll come back in 10 minutes, children. Please do your work. Srijit, ready with answers?
I'm done with it's not very much. Yes, ma'am.
Okay. Yeah. Okay, so check your steps. It's okay if we were not able to do, that's fine. We'll understand now. It's just for you to realize if you are able to do or not. So now you can get your doubts clarified. If we were not able to do, you can get your doubts clarified now. Okay, so first 12.95.
Ma'am, I'm 259.
Okay, ready? So 12.95. 12.95 is equal to, in the Mari question pattern, is fourth standard. So 1295 by 100. Because after the decimal point, 2 digits, no? So 2 zeros. Now you should simplify this. How should cancel? Yeah, 5 20 times. 5 20 times, and then 5 2s are 10, 2 remains. 5 5s are 25, 4, 5 9s are 45. Now, Navneet, I'll answer your question. Now, you wanted to know how do we know that the number is in the simplest form and it cannot be simplified any further. Now, look at the smaller of the two numbers, 20. Now, 20 is divisible by which prime numbers? 2, 5, that's it. Prime numbers, 2 and 5. Is the numerator divisible by 2 and 5?
Oh no.
See, we first simplified in the tables using the tables of 5. Now we have 259 by 20. Now our question is, your question is, how do I know that this is the simplest form and it cannot be simplified any further? The answer for that is, look at the smaller of the two numbers, 20. Now 20 is divisible by which prime numbers? 2 and 5, right? Now is the numerator divisible by 2 and 5 or 2 or 5? No, the numerator 259 is not divisible by 2. It's not divisible by 5. Then that's the simplest form. The denominator 20 is divisible by 2 and 5. The numerator 259 is not divisible by 2. It's not divisible by 5. Then this is the simplest form. This is the simplest form. So first let x be equal to 12.9555 going on forever. Okay, that's the first step. See, you can see it here. It was given 13.615 recurring. So I wrote it as 13.6151515 going on forever. That's what is important here. Nine, 5 repeats. Only 5 repeats. The bar I place only on top of 5. Okay, the board. Correct? Now only one digit repeats, right? So you'll have to use 10 and you'll have to find 10x. In the decimal part, one digit repeats itself forever. So the number you'll have to use is 10 and you'll have to find 10x. So what is 10x? 10x is equal to, see, 12.9555. So when you multiply by 10, you'll have to shift the decimal point to the right by one place. So 129.555 going on forever. So it's 129.5 You can write how many ever 5s you want going on forever. Because 5 is endless. Okay, so this is equation 1. This is equation 2. Now you need to perform equation 2 minus equation 1 gives. That's because 2 digits repeated. So 10x is equal to 129.5555 going on forever. X is equal to 12, write carefully, 0.955. Stop. Now you'll have to subtract. 9x is equal to 10x minus x is 9x is equal to, now 5 minus 5 0, 5 minus 5 0, 5 minus 5 0. So you can just slash this first. Now this becomes 8, 15, 15 minus 9, 6, 8 minus 2, 6, 1, 1.
This is equal to 116.9. 6.6 by 9. And for question we got 1283 by 99. Final answer.
So 9x is equal to 116.6. You don't have to write these zeros. Okay. Sorry, 1 divided by what?
10. 10.
10. We're shifting the decimal point.
Then x is equal to 1166 by 10.
Now, take this number which is in the numerator and any one number from the denominator, say 10. They're divisible by 2. So simplify. So 2. 2 how many times? 2 5s are 10, 2 8s are 16, and 2 3s are. This is 5 times. Now check what is 5 plus 8? 13. 13 plus 3, 16. It's not divisible by 3. But in the denominator, what you have? You have 5. You cannot simplify 583 and 5. Then what about 9? It's divisible by 3. But the numerator is not divisible by 3 according to the test of divisibility. So that's the simplest form. So x is equal to 583 divided by 45. That's all. That's the answer. Now 583 divided by 45 is 12.95 repeating. 583 by 45 is 12.95 going on forever. Now, what is the, yeah, so you have taken the question incorrectly. What is the P by Q you've got?
1283 by 99.
1283 by 99. You got the same thing, right? 1283 by 99. You didn't bring the 99 for division. You left it 99x is equal to, yeah, 12.959595. Correct, yeah. In the exam, you will not get marks. If you take the question incorrectly, you will not get marks. Be careful, yeah. So what did you do? You also took 95 recurring, is it?
Okay. Ma'am, I put correct, ma'am. The question I put correct, ma'am. But they said the question is wrong. They both put the wrong question. I told them.
Okay.
Told that ma'am won't give that.
ஒரு digit தானே அப்ப 10 தான் யூஸ் பண்ணும். 2 digit repeat ஆனா தான் 100. 1000. That's why see you should get You must try all those sums so that you get confused and get the correct version. So in the test, you're very clear. At school, you're very clear with the concepts. Okay, is this fine?
Yes. Another person we wrote I like it.
Srijit?
Ma'am?
Yeah. Did you get the correct answer?
Yes, ma'am.
Okay. Next one. That's all. 0.37 is 37 by 100. Finished. Yes or no?
Yes, ma'am.
0.37 recurring. Okay. So you can say y also. Let y be equal to 0.373737 going on forever. This is the first step. Now, in the decimal part, 2 digits. 3 and 7 are going on forever. 2 digits. So 100. You should find 100 y. Okay, I'll use x only. I'm saying you can use any variable.
I'm using.
Yes. Yeah.
100x.
Okay, 100x.
Equal to 0.37 by.
See, when you multiply 0.373737 by 100, you must shift the decimal point to the right by 2 places because 100, no, so 2 places. So it'll become 37.3737 going on forever.
Ma'am, 03737. I wrote 037.
This has no meaning.
Yes, ma'am. Even I wrote. I wrote 6. Ma'am, both are the same.
But you should not use. You're in 8th standard. You should know that the 0 has no value. You should not write it. Why should you write the zeros which have no value? No, no. You should be clear.
No, I know that it's 37 only. Can we just say the final number we got it as 8.
Is this correct?
Yes, ma'am.
37. 37.373. You can write. That's going on forever.
And then equation 1, equation 2. And equation 2 minus 1 gives 100 is equal to 37.37.
3737.
Ma'am, I just put 137. Is it okay?
No, not okay.
I'm going.
You should show at least 2-3 sets in the repeating block.
And x is equal to 0.3737. And then 99 x is equal to 37.0.
Because 100x minus x, not 10. 100x minus x is 99x is equal to. Now see 7 minus 7, 0. 3 minus 3, 0. 0, 0, 0. You don't have to write the zeros. Don't write the zeros. Flash this. 37 minus 0 is 37. So x is equal to 37 by 99. That's the answer. 37 by 99. Srijit, any questions, any clarifications? Should I clarify anything?
No, ma'am. We did it.
Okay. Srijit, your school follows the NCERT maths textbook, is it?
Yes. Yes, ma'am.
Okay. One second, 1 second. Yeah, Srijit, I want the answer from you. What's the P by Q form of this decimal number?
2,497 divided by 100.
See, your friends understood your answer better. You're telling me the simplest form. I want the immediate step. What should I write after this?
62,425 divided by 1,000, ma'am.
Very good. Then simplify. So in the tables of 5, how many times?
500, ma'am.
In the tables of what? 500 times? 2.
2.
The numerator is not divisible by 2. Okay, what's your final answer? Okay, you have simplified. Sorry, okay, I won't bother you much. What's the final answer you got after simplifying?
2,497 divided by 100, ma'am.
2,497 divided by
100, ma'am.
100? No.
I'm sorry, ma'am. It's wrong, ma'am. I did it some mistakes.
No, that's what you've divided the numerator by numerator. What did you say? 2,000?
2,497, ma'am.
Okay, so please do the division again. You've gone wrong while simplifying. Okay, so when you divide, see 6, 2, 4, 2, 5. When you divide by 5, what do you get? 5 1s are 5. 1 remains, 2 comes down. 2s are 10. 2 remains, 4 comes down. 5 4s are 20. 4's remainder. What comes down? 2 comes down. 8's are 40. 2 remains, 5 comes down, and 5's are. So it's 1, 2, 1, 2, 4, 8, 5 divided by 200 times. I think here you went wrong. 1 second, give me a minute, Srijit.
Ma'am, I got the answer, ma'am. Ma'am?
Yeah,
Ma'am?
Yeah, I'm here. No, I had to answer
I
the
got
door.
the final answer, ma'am.
Yeah, tell me the final answer.
The answer is 2,497 by 40, ma'am.
So I think denominator you went wrong while simplifying, right? Okay, fine. Finally, you got it right. Okay. This is the correct answer. All of you got it here?
Yes, ma'am.
You didn't simplify, is it? Where did you stop? Okay. Yourself? You simplified? I'll check your book later. Okay. Both of you are very quiet. I can't make out. Here, boys, you got 2,497 by 40? Okay. 62.425. Next one is 62.425 recurring. So let x be equal to 62.425. Write it about 3 times, and this is equation 1. Then since 3 digits repeat, 4, 2, and 5. In the decimal part, 3 digits repeat. So you should use the number 1000 and find 1000x. 3 digits or 3 zeros? 1000. That's the right way of saying. One is not seen as the right way of saying. So 1000x is equal to 62,425. You can write, yeah. No, that's what I'm saying. It's not that there are 3 sets. There are infinitely many sets. You can write how much you want. You can write
the number of times we wrote in the first equation.
You should write the same number of times in the second equation so that you have digits exactly one below the other.
And then X is equal to 62.425 minus E by 1 gives 1,000 is equal to 62,425.425.
Right.
62,420. X is equal to 62.425,425,425. 999. Ma'am, 62,906 is equal to 62,363,999.
Yeah. Thank you. So 1000x minus x is 9,000. Sorry, 999x equals. Children. Yeah. I'm happy that you all got it right. 1 second. So 5 minus 5, 0. 2 minus 2, 0. 4 minus 4, 0. So the decimal part, you can just cancel out like this. So here 5 minus 2, 3. And borrow 12 minus 6, 6. 3, 2, 6. So x is equal to
62 by 99. It cannot be simplified. So the simplest answer.
So x is equal to, I'm just continuing here, x is equal to 62363 divided by. Now use a test of divisibility. 6 plus 2, 8, 8 plus 3, 11, 11 plus 9, 20. Okay, 20 finally, yeah. 20 is not divisible by 3. When you find the sum of the digits in the numerator, it's 20. It's not divisible by 3. So denominator is divisible by 3.
But the numerator is not.
Yeah. So you can just.
11 also is not divisible in the numerator, so that's it.
Yeah. All right. Now when you do 62,363 divided by 999.
We get 62.4.
62.425. 62.425 going on forever.
Yes, ma'am.
All right. So the notes, till this point, I'll share on WhatsApp with you. Follow the instructions on WhatsApp. All right. All right, Shagit. Thank you. You may leave the call.
Thank you, ma'am.
Yeah, thank you. Thank you.